the other thing is they study femtosecond phenomena. So I'm not sure how good you are with your prefixes, powers of 3, but femtosecond is 10 to the minus 15 seconds, right? Picosecond, nanosecond, picosecond.
Oh, yeah.
Right? No problem. There's attosecond, I think zeta second comes in somewhere down the line. 10 to the minus 15 seconds. So they create pulses of light that are 10 to the minus 15 seconds long. The reason they do that is to make stop-action movies of chemistry. So it turns out that chemical bonds, orbiting of electrons and things, if you really look at the speed that the electrons are traveling and how fast you need to snap that to stop the motion, roughly. Now, Heisenberg's rolling over his grave. He can't stop the motion, but you need something on the order of femtoseconds. So they create about 100 femtosecond type pulses of light. And what that means is they can literally make a stroboscopic movie of a chemical reaction as it happens.
Oh, wow.
They can capture all those intermediate states of chemistry that we never used to even know about, right? You mix
Wow.
two things, and one thing, you get something else. And, you know, there's 100 intermediate states. And what you really want to do is have a good model of chemistry so that you can engineer processes, fuel cells, you know, whatever you want to do. So these are ways that you can fine-tune your model. You know, you say, well, my chemical model says it has to have this state, this state, this state. And you do the experiment and it has a different state in there, and you got to figure out a different model. So the new light sources, the linear light sources, are all about making short pulses of light. So they're going femtosecond, even attosecond pulses of light. And it's all about dynamics, chemical dynamics. That's sort of the next frontier of study in these light sources. And we're actually proposing one at Berkeley Lab, the NGLS. Maybe you've heard bantering about it. It's a similar facility to the LCLS, and we hope to build that in the next sort of 10 to 15 years. We're actually going to build a tunnel from the botanical garden back there underneath us, almost. Come out where the old Evitron accelerator is. So hopefully they'll give us money for it. So as we walk along, one good thought, two ways to think about a femtosecond that are kind of fun. One, you all know that light travels very quickly, right? 8 minutes from the sun to the earth and all kinds of other examples. Well, light travels about 1 millimeter in 1 femtosecond. So that kind of gives you some picture of how short a femtosecond is. The other way I kind of like to think about it is that, you know, the universe is 14 billion years old, give or take. There are as many seconds, there's as many femtoseconds in 1 second as there are seconds in the age of the universe.